Hello, my name is Henry Langston. I'm Product Manager at Ocean Optics. Today I just wanted to introduce you to some of our application demonstrations at Pittcon here in Atlanta. Protecting the environment is one of the things that we're most passionate about at Ocean Optics. We have a goal to take spectroscopy out of the lab to the sample. Here we're monitoring oil and water by looking at the fluorescence emission in our simulated oil rig setup here. So if you can imagine an oil rig in the Gulf of Mexico or even in the North Sea, any oil leak has a potentially huge environmental impact. With simple spectroscopy setups like this, we can very easily monitor in real time the levels of oil in the water, either around the pipelines, on the rig, or even at remote buoys. We can turn on our simulated oil rig, and our spectrometers are measuring the fluorescence emission of the oil in the water, and once it reaches a certain threshold level, they're triggering a particular alarm. There it goes, right on cue. There are a host of different environmental monitoring applications that you can use spectroscopy for, but of course we're not just limited to environmental monitoring. Ocean Optics get involved in all sorts of different markets and application areas, and now I'd like to talk to you about some of our work in food and food integrity. Traditional quality and safety testing of food is destructive, requires long sample processing times, and is often very expensive. With UV-Vis, NIR, and Raman spectroscopy, we can make rapid, non-destructive tests that can be done in situ, in process, and in the field. Here we're combining a dual-channel UV-Vis flame spectrometer with our new flame near spectrometer with a bifurcated fiber and a diffuse reflectance probe, which we can use to easily measure the quality and freshness of different foodstuffs. Here I'm using the example of measuring both the color, consistency, chlorophyll content, anthocyanin content, and moisture content of various different apples. I can measure a green apple, separate it from red apples, measure the relative moisture content of both, and very easily I can spot with spectroscopy adulterated produce. Of course, this is not just limited to apples. This can be used for meat, grains, almost anything that we eat. If we take, for example, measuring trace levels of pesticides, we can use techniques like Raman and SERS, surface enhanced Raman spectroscopy, to measure very, very low levels of these trace contaminants. For more information about Ocean Optics, our applications, and our products, visit www.oceanoptics.com.